Yeah. Okay.
Yes, can do that. Sorry about that. I was in this like weird limbo. I don't know if I should jump on yet. But good morning, everybody. It is so nice to, I guess, be here with you virtually. I am Megan, and I am from the National Renewable Energy Laboratory located in Golden, Colorado. And today we are going to be talking about one of my favorite scientists. And it's actually a scientist that without all of his work, I probably wouldn't have a job. So we're going to be reading a book that's all about Albert Einstein. And one of his big theories was in light and how light actually works. So light is a really important form of energy for us at the National Renewable Energy Laboratory because we like to use things like solar panels to get electricity to, say, your house. So that's really fun. So without further ado, I am going to read On a Beam of Light by Jennifer Byrne. And we're going to learn all about Albert Einstein. And then afterwards, we're going to do just a little experiment to learn more about these particles and waves that he talks about a lot in his theories. So let's get started. On a Beam of Light, a story of Albert Einstein. Over 100 years ago, as the stars swirled in the sky, as the earth circled the sun, as the March winds blew through a little town by a river, a baby boy was born. His parents named him Albert. Albert turned 1 year old and didn't say a word. Albert turned 2 and didn't say a word. Albert turned 3 and hardly said any words at all. He just looked around with his big, curious eyes, looked and wondered, looked and wondered. His parents worried. Little Albert was so different. Was there something wrong? But he was their baby, so they loved him, no matter what. One day, when Albert was sick in bed, his father brought him a compass, a small round case with a magnetic needle inside. No matter which way Albert turned the compass, the needle always pointed north, as if by an invisible hand. Albert was so amazed, his body trembled. Suddenly, he knew there were mysteries in the world, hidden and silent, unknown and unseen. He wanted, more than anything, to understand those mysteries. Albert started asking questions. Questions at home, questions at school, so many questions that some of his teachers told him he was a disruption in class. They said he would never amount to anything unless he learned to behave like all the other students. But Albert didn't want to behave like all the other students. He wanted to discover the hidden mysteries in the world. One day, as Albert was zipping through the countryside on his bicycle, he looked up at the beam of sunlight speeding from the sun to the earth. He wondered what it would be like to ride on one of those sunbeams. And in his mind, right then and there, Albert was no longer on his bicycle, no longer on the country road. He was racing through space on a beam of light. It was the biggest, most exciting thought Albert had ever had, and it filled his mind with questions. Albert began to read and study. He read about light and sound, about heat and magnetism, and about gravity, the invisible force that pulls us towards our planet and keeps the moon from floating away into outer space. And he read about numbers. Albert loved numbers. They were like a secret language for figuring things out. But all that reading didn't answer all of Albert's questions. So he kept on reading and wondering and learning. When Albert graduated from college, he wanted to teach the subjects he loved, all the things he had read about for all those years. But Albert couldn't find a job as a teacher, so he got another job. A simple, quiet job in a government office. an office where he worked with other people's ideas and inventions. He did his work very well and very quickly. So quickly that he had lots of extra time to think and wonder. Albert watched a lump of sugar dissolve and disappear into his hot tea. How could this happen? He watched the smoke from his pipe swirl and disappear into the air. How could one thing disappear into another? Then he began to figure it all out. He thought about the idea that everything is made out of teeny tiny moving bits of stuff, far too tiny to see, little bits called atoms. Some people didn't believe that atoms existed, but Albert's figuring helped prove that everything in the world is made of atoms, although even atoms are made out of things. So now we know that even atoms are made up of even tinier things. What? Even sugar and tea, even smoke and air, even Albert and you, even this book is made of atoms. Then Albert thought about motion. He realized that everything is always moving. And while that might seem hard to believe, if you think about it, even though I'm sitting in this chair right now, the earth is spinning and I'm on the earth, which means that I must be spinning. So it's weird that I can look like I'm sitting still. Moving through space, moving through time, even sound asleep, we're moving as our planet circles the sun and our lives travel into the future. Albert saw time and space as no one had ever seen it before. Albert wrote down his new ideas, put them into envelopes, and sent them to science magazines. The magazines printed everything Albert sent. He hoped that scientists and professors would be interested, and they were. They were very interested indeed. They asked Albert to come work with them and teach with them. Yay, Albert's finally getting to do his dream. For the first time in his life, people started to say Albert is a genius. Now Albert could spend all his days doing what he loved, imagining, wondering, figuring, and thinking. Albert thought about very, very big things, like the size and shape of the entire universe. He thought about very, very small things, like what goes on inside the atom that makes up everything. He thought about mysterious forces like magnetism and gravity. He discovered whole new ways to understand how all these things worked. Everywhere Albert went, he would think and think. One of Albert's favorite thinking places was his little sailboat. He loved to let his mind wander as the wind blew him across the water. Sometimes when Albert was having a tough time with a tricky problem, he would put it aside and play his violin. Music made Albert happy. He said it helped him think better. Albert even chose his clothes for thinking. His favorites were comfy old saggy baggy sweaters and pants, and shoes without socks. He said now that he was a grown-up, no one could tell him to put on his socks. And he says, my feet are happier without socks. In the town where he lived, he became known for wandering around, deep in thought, sometimes eating an ice cream cone. Always recognizable with his long, wild hair, which by then had become quite white. Everywhere Albert went, he tried to figure out the secrets of the universe. And he never forgot about the beam of light that he rode on so long ago in his imagination. Albert figured out that no person, no thing could ever zoom through space as fast as a beam of light. He figured that if he could travel near the speed of light, crazy things would happen. Only minutes would pass for Albert, while years and years went by for the rest of us. This idea was so amazing, people didn't believe it at first. But scientists today have proven that it's true. Albert thought and figured until the very last minute of the very last day of his life. He asked questions never asked before, found answers never found before, and dreamed up ideas never dreamt before. Albert's ideas helped build spaceships and satellites that traveled to the moon and beyond. His thinking helped us understand our universe as no one ever had before. But still, Albert left us many big questions. Questions that scientists are working on today. Questions that someday you may answer by wondering, thinking, and imagining. So, a big reason that I love this book is that I think a lot of times people have this perception of scientists that, one, all of our ideas are always going to be right and are always going to be accepted by everybody else. And actually, even Albert Einstein, for many of his ideas, he thought he was wrong about them. So even he didn't have confidence in ideas. And now we know that most of them are true. So just keep that in mind as you are becoming a new and budding scientist, that even if you have an idea that's crazy and you don't believe it and you don't think that anybody else could believe it, one day it could prove to be life-changing for all of us. So keep that in mind. And on that note, I want to talk about one of the big things that Albert Einstein contributed to science, which is his idea of particles and waves and how they kind of act together. So let's start with particles first, because particles are a little bit easier to understand because you guys have seen things that act just like particles before. So you might remember the book talked about those little tiny particles that we call atoms. Atoms act kind of like this block. So this block is a solid. I can put it in my hand, it stays the block. I push on it, and while this one is filled with air, so it can squeeze in a little bit, doesn't squeeze in that much. And if I threw this, somebody could catch it, because this particle is made of something. This is made of plastic. Plastic is made up of a whole bunch of different atoms that come together to make it. A lot of carbon, a lot of hydrogen, some oxygen in there, probably some other stuff, a little bit of, probably lots of stuff. And it comes in lots of different forms. Particles can come in lots of different forms. Here, you'll see that I have this little round ball. It is still a solid. I put it in my hand, and it doesn't change its shape. I can push on this one, and it stays. So this is what a particle is. And you can think of a particle kind of being like a block. So it's very solid. Oh, do I have a question? Or do I just have somebody joining? Oh, there we go. Okay. So now let's take a second and let's explore waves. You guys have probably seen waves before because you might have either been to the ocean, or maybe you have seen the ocean in a movie that you were watching. There was a really fun movie a while ago that came out, Moana, that was set on the ocean. So you guys might have seen waves before in water. And I'm gonna show you some waves right here. So if you are following along and you have your bowl of water, you can do this with me. I want you to just poke your finger in the middle of your bowl. And you can see the waves that I'm making even by poking this bowl with my finger. You can see that the water goes out and back and out and back. And if we had a really good camera, we would see that it continues doing that for a really long time. Now, we saw that Albert Einstein was talking about light. So let's take a second and let's look at some light waves, because it turns out light, when we consider it, is acting like a wave too. So let's watch what happens when I put my finger in. So in my back shadow, the light actually helps us see the waves. And you can see when I tap on my table, I make waves. You can see all of them moving in the shadow. So that's how we know that light is also traveling like a wave. But one of the crazy things that Albert Einstein said that we now know to be true is that for light to have all of the properties that we know light has to both be a particle and a wave. But I want you to think about that, because that is crazy. Because if you were to try to throw an ocean wave at me, I can't catch that. I could catch the water that is showing the wave, but I couldn't catch the wave. And I can't catch a light, right? I can't catch that in my hand. But Albert Einstein insisted that light was both a wave, like we see here, and a particle, like we see here. And it turns out that this duality of working as both a wave and a particle is really important to solar energy. We use the fact that light acts as a particle when that we are having our solar panel absorb the sunlight. What? So at this point, we know that Albert Einstein was telling the truth and had this like crazy idea. And don't get me wrong, he even thought it was crazy. But now we know that it's true. And that's what's so exciting about science, is that so many things that you might look around and you might have an idea about might seem really crazy to you. And even if you tell your parents might be like, that's a weird idea. But just know, it could be right. And that's what's super exciting. I want to thank you guys so much for joining me. I don't think there's any way for me to take questions, but that's okay. I have been so honored to join you guys. And once again, we read On a Beam of Light by Jennifer Byrne, in case you want to check out that book yourself.
Awesome. Thank you so much. That was great.
Yeah, thank you. Bye, everybody.
Bye.